Hello, bachas. Welcome back to the channel, the F in Physics, where the F in Physics stands for fun. Now, in this video, we are going to talk about Snell's law. Okay, so Snell uncle ne kya kaha? He said that refractive index, which is a ratio of sine of angle of incidence to sine of angle of refraction, is also equal to velocity in medium 1 upon velocity in medium 2, provided this is refractive index of medium 2. And this is what we have to prove, that sin I upon sin r is equal to v1 upon v2. For that, what we will assume is that there is a wave which is moving from medium 1 entering medium 2. Okay, so the red wave fronts that you see are the wave fronts in medium 1. The distance between the wave front is my wavelength in medium 1, and therefore the velocity in medium 1 is wavelength upon time, which implies that wavelength in medium 1 is velocity in medium 1 into time. This is about medium 1. Now let's go to medium 2, which is represented with blue color. Okay, there are two wave fronts. Obviously you will see that the wavelengths are different because there's a change in medium. If I drop a perpendicular over here, then this represents my wavelength in medium 2. So if I assume that velocity in medium 2 is v2, which is wavelength in medium 2 upon time, so beta I get wavelength in medium 2 is velocity in medium 2 into time. Remember, both the time values are the same because even though the speed changes, the wavelength changes, the frequency remains the same. Okay, ignore the dogo behind, he just approves whatever I'm saying. So my time is going to be the same. Now before we go ahead, let me first draw a normal and mark the angle of incidence, which is in medium 1, and angle of refraction, which is in medium 2. अब थोड़ा ट्रिग्नोमेट्री का हेल्प लेते हैं. पहले नामकरण करते हैं. सो दिस इज ए बी सी and this is D. Okay, let's play with angle now. So in triangle ABC, this one that you see over here, ABC, angle B is 90 degree. Okay, I want you all to focus here. This complete angle is also 90 degree, out of which ये छोटू सा part is angle I. So the part which is left becomes 90 minus I. Correct? Let angle A be X. So if I sum up all the angles of triangle ABC, which is X, plus angle B, which is 90, plus angle C, which is 90 minus I, all of them will be equal to 180 degree. When you solve this, you get angle X as angle of incidence. I'll just make a note of it. So X becomes angle I. Okay, I'll erase the remaining part because it's not required. Now I move on to the second part. Understand this. This angle over here is 90 degree, right? Also, this angle here, the interface and the normal, is also 90 degree. Correct? So if I shift this direction of the wave by an angle X, so it overlaps with the normal, can I say ये जो blue line है, even that will shift by the same angle? So technically this angle is my angle of refraction. Correct? So again I'll erase everything because I don't need them. Now if I only focus on the angles, if I use trigonometry, let me zoom in. Now I'll write everything on the left hand side. So sin I becomes opposite, which is my BC, which is the distance between two wave fronts, which is lambda of medium 1 divided by the hypotenuse, which is AC. In medium 2, sin R is opposite, which is AD, which is my lambda 2, divided by the hypotenuse, which is again AC. So if I find the ratio, bachas, I get sin I upon sin R is lambda 1 by AC, the whole divided by lambda 2 by AC. AC cancel हो गया. What I'm left with, lambda 1 by lambda 2. Now we go back to the value of lambda 1 which we had found out. Lambda 1 was V1 times T, and lambda 2 which we found out was V2 times T. Again we had said that T remains constant, so I can get rid of that. So what I'm left with, sin I upon sin R is V1 upon V2, which is my Snell's law. यही proof करना था ना. So I hope this video on Snell's law is clear to you all. Thank you.